So now that we have this, let's go ahead and evaluate. The first thing I want to do is change it. Y was my up-down value. It is the absorbance equals 17,660 times the concentration, which was max, plus 0.409. Okay, now let's plug in some values here, or units. Absorbance was measured in A, so that's going to be A. Concentration was measured in molarity, so my Y over my X will be absorbance, or A, divided by molarity. There's a couple ways you can do that. You can do A divided by M. I personally don't like that because I don't think it looks nice. So what I do instead, if I come up here to insert, I can do insert equation. And then over here, there's an option for writing things as a fraction. Purely just my OCD speaking, making me insist on doing things fancy-like, but it helps delineate and set it off and make it a little clearer. That is the first step. The next step we got to talk about is what do those mean? Well, if at concentration 0, we still have this small amount of absorbance. So this is our baseline, or almost inevitably what we'll call it is our initial absorbance. Another way to shorthand this, if you prefer, is A, and then you can use your control and comma to make a subscript, and then you can do not or initial for I for initial. Either way works. Take your pick. I'm going to use the not because that's just how I think. The 17,660 is a rate. It's dependent. It's something. But it's going to be the rate of absorbance, rate of absorbance increase. Take your pick of phrasing. Come up with a term for it. If there was a specific term, I'll tell you about it. We'll learn it down the road. But right now, we'll just call this rate of absorbance. Okay?